Beyond the orbit of Neptune lies a realm of darkness and ice, a mysterious frontier where sunlight is dim and time seems to stretch. This is the Kuiper Belt, a vast ring of icy bodies and dwarf planets that extends billions of kilometers into space. At infinity beyond, we see this distant region not as the end of the solar system, but as a new beginning, one filled with ancient secrets and uncharted worlds. For decades, Pluto was considered the ninth planet of the solar system, its icy orbit dancing through the outermost reaches of the Sun's gravitational grasp. But in 2006, Pluto was reclassified as a dwarf planet by the International Astronomical Union. This decision sparked passionate debate, but it also opened the door to a broader understanding of the diverse and dynamic world Pluto truly is. In 2015, NASA's New Horizons spacecraft performed the first flyby of Pluto, transforming it from a blurry point of light into a stunning, complex world. What we saw was breathtaking. Vast plains of nitrogen ice, towering water ice mountains, a thin blue atmosphere, and a massive heart-shaped glacier named Tombaugh Regio. Even more astonishing, Pluto shows signs of ongoing geological activity, despite its small size and frigid location. Pluto's surface is young in many areas, with few craters and flowing nitrogen glaciers, suggesting that heat is still moving from the interior. Beneath the icy crust may lie a subsurface ocean of water, kept liquid by heat from radioactive decay. This hidden ocean raises fascinating questions. Could it support microbial life? Could Pluto, so distant and cold, be more than just a frozen relic? Orbiting Pluto is Charon, its largest moon. So large relative to Pluto that the two bodies actually orbit a common center of gravity outside Pluto itself. Charon's surface shows signs of ancient fractures and possible cryovolcanism, hinting that it too may have once been geologically active. The Pluto-Charon system behaves more like a binary planet than a typical planet-moon pair. But Pluto is not alone. The Kuiper Belt is home to thousands of other icy worlds. Among the most notable is Eris, a dwarf planet slightly smaller than Pluto but more massive. Discovered in 2005, Eris played a major role in triggering Pluto's reclassification. Its highly elliptical orbit takes it far beyond Pluto, into regions where temperatures plunge below 240 degrees, 400 degrees. There's also Makemake, Haumea, and countless unnamed objects that drift in silent orbits, worlds that may hold clues to the solar system's formation and evolution. These are remnants of the primordial disk from which the planets formed, icy time capsules preserving the chemistry of the early solar system. Despite their distance and remoteness, missions to the Kuiper Belt are gaining momentum. New Horizons, after its Pluto encounter, went on to visit Arrokoth, a contact binary object shaped like a flattened snowman. This revealed insights into how planetary building blocks may have gently merged in the early solar system, rather than violently collided. Future missions are being proposed to orbit Pluto or explore multiple Kuiper Belt objects, KBOs. These missions would help answer fundamental questions. How did these icy worlds form? Do they possess oceans beneath their crusts? Could life, even primitive and microbial, exist in such extreme environments? At infinity beyond, we view the Kuiper Belt not as the edge of the known, but as a threshold. It marks the border between what we've explored and what still waits in the deep unknown. And in this distant expanse, these small frozen worlds may hold keys to understanding how planetary systems emerge, and how life might arise even in the coldest corners of the cosmos.